Hi, my name is Naratika Natasha, and I'll be presenting about the zero error positive, and zero error negative. So, what does it mean by error? Error is the difference between the actual value of a quantity and the value obtained in measurements, while systematic error tend to shift all measurements in a systematic way so their mean value is displaced. Systematic errors can be compensated if the errors are known. So there are three examples of systematic errors. First, zero error, which caused by an incorrect position of the 0 point, and that means when the starting point did not start at the value of 0. And second, an incorrect calibration of the measuring instrument and consistently improper use of equipment. Although systematic error can be reduced by conducting the experiment with care and repeating the experiment by using different instruments. So, there are three types of zero error. First, zero error arises when the measurement instrument does not start from exactly 0. And second, zero errors are consistently present in every reading of a measurement. And third, the zero error can be positive or negative. From the picture I attached below, we can see that the first picture have no zero error because it starts with exactly 0 on the instrument, while the negative zero error starts before the 0 and positive zero error starts after 0. So it's how this zero error occur.
Next, thermometer. A thermometer is an instrument that measures temperature. It can measure the temperature of a solid, such as food, a liquid, such as water, or a gas, such as air. The three most common units of measurement of temperature are Celsius, Fahrenheit, and Kelvin. Principle of thermometer. A thermometer works on the principle that solids and liquids expand on heating. As the temperature rises, mercury expands, causing it to move upwards and depict the temperature. As we can see, this is the diagram of smaller scale of thermometer. The 0 point on the Kelvin scale is known as absolute zero. It is the lowest temperature that can be achieved. Here, I list some type of thermometer, which is laboratory thermometer, clinical thermometer, mechanical bimetal thermometer, and infrared thermometer. So first, laboratory thermometer. Laboratory thermometer is an example of liquid in glass thermometer that fill mercury or alcohol. It is normally used in simple laboratory experiment where temperature is measured. In this thermometer, the volume of the liquid changes when the temperature changes. Next, clinical thermometer. This thermometer is used to measure human body temperature. It has limited scale, which is 34 to 50 Celsius and constriction. It is more accurate and will give an exact temperature. This thermometer uses an electronic sensor to detect body temperature. Its simple use makes this thermometer widely used for health purpose, laboratory purpose, and cooking purpose. Mechanical bimetal thermometer. This kind of thermometer is used to measure the temperature of thermostats, ovens, grills, and other industrial tools as an indicator of a heat threshold. The working principle of this thermometer is that when a hot temperature occurs, the bimetal strip will bend towards the metal with a high expansion coefficient or vice versa. The typical range for this thermometer is 40 to 800 Fahrenheit. Lastly, infrared thermometer. An infrared thermometer is a thermometer for measuring the temperature of a certain object or body part without touching the object because it uses infrared or laser light. The way it works is by detecting thermal radiation emitted by object with infrared light. This type of thermometer is commonly used recently.
Next is a vernier caliper. Vernier caliper is a measuring device that consists of a main scale with a fixed jaw and a sliding jaw with an attached vernier. Principle of vernier caliper. The vernier caliper uses the principle of alignment of line segment to determine the more accurate reading. The length of the object to be measured is placed in between the two jaws of the vernier calipers. Certain graduation on the vernier scale gets signed with a reading on the main scale. The decimal value of the measurement is obtained by adding vernier caliper value to the main scale. Next is a part of vernier caliper. First is a inside measuring surface. Second, inside measuring jaw. Third, set screw. Main scale. Depth standard surface. Depth bar. Main scale graduation. Vernier graduation. Thumb grip. Slider. Outside measuring jaw and outside measuring surface. Okay, how to measure the vernier caliper? On the vernier caliper, the main scale is divided into millimeters. The vernier scale is 9 mm long and consists of 10 divisions. Each division on the vernier scale then is 0.9 mm long or 0.1 mm less than the main scale division. Therefore, the number of the vernier line which is the best aligned with a line on the main scale is equal to the number of tenths of a millimeter beyond the last reading of the main scale at the zero mark on the vernier scale.
A micrometer is a measuring instrument that is widely used in the mechanical engineering field. It is used for measuring extremely small dimensions. A screw gauge can even measure dimensions smaller than those measured by the vernier caliper. Micrometer belongs to the family of calipers and also consists of two different scales. There are three main types of micrometer, which is the first one, outside micrometer, the second one, inside micrometer, and the last one is the micrometer.
Moving on to the principle of micrometer. The basic principle of operation of a micrometer is as follows. The amount of action movement of a screw that is made accurately can be measured by the amount of rotational movement of it. This is because the pitch of the screw is constant. The measurement made due to the rotational movement is some amplified form of the actual axial movement of the screw. Moving on to the unit of micrometer. The micrometer, also commonly known as micron, is an SI-derived unit of length equaling 1 times 10 to the power of -6 meter. That is 1/1000th of a meter. The smallest possible reading on the thimble scale of a micrometer is 0.01 millimeter, while the biggest possible reading is 0.49 millimeter. Outside micrometer is used for measuring the thickness or outside diameter of small parts and objects. It is available in the shop in 12 sizes of inches. Outside micrometer measure 1 inches increments and it is accurate to 4 decimal places. Inside micrometer is used to measure the inside diameters and internal dimensions of holes, bores, and other openings. 3-point inside micrometers have a gauge head with 3 contact points that creates a self-centering measurement. Depth micrometer is used to measure the depth of an object with precision and accuracy with least count of 0.01 millimeter. The measuring span is 25 millimeter, just like in micrometer, that can change by changing offsetting rod.
Voltmeter is an instrument used for measuring the electrical potential difference or voltage in volts between the 2 points in an electric circuit. It works on the principle that the torque is generated by the current which induces because of measuring voltage, and this torque deflects the pointer of the instrument The deflection of the pointer is directly proportional to the potential difference between the 2 points. The voltmeter is always connected in parallel with the circuit. The voltmeter constructed in such a manner that the internal resistance always remains high, means that no current should flow through them. If it connects in series with the circuit, it minimizes the current which flows because of the measuring voltage. This disturbs the reading of the voltmeter. The voltmeter always connects in parallel with the circuit so that the same voltage drop occurs across it. The high resistance of the voltmeter combines with the impedance of the element across which is connected, and the overall impedance of the system is equal to the impedance that the element had. The voltmeter is constructed with a very high internal resistance because it measures the potential difference between the 2 points of the circuit. The voltmeter does not change the current of the measuring device. The unit of the voltmeter is the unit of the voltage measured in the voltmeter. The symbol for potential difference of voltage is capital letter V. The unit of potential difference of voltage is volts. The units of voltmeter are millivolt, kilovolt, and volt. These three are the most used units. 1 volt equals to 0.001 millivolts and 1 volt equals to 1000 kilovolts. Smaller scale is 0.1 volt. The uncertainty from reading the scale is plus minus 0.1 volt. The voltmeter can be read to 2 decimal places. Example 1.00, 1.25 and 2.50. The voltmeter on the left has an analog scale. The reading should be 2.01. Meter is an instrument for measuring either direct or alternating electric current in amperes. An ammeter can measure a wide range of current values because at high value, only a small portion of the current is directed through the meter mechanism. A shunt in the parallel with the meter carries the major portion. The meter is connected in series with the circuit so that the whirl electrons of measuring current passes through the ammeter. The power loss occurs in the ammeter because of the measuring current and their internal resistance. The ammeter circuit has low resistance so that the small voltage drops occurs in the circuit. The main principle of ammeter is that it must have a very low resistance and also inductive reactance. Now, why do we need this? Can we connect an ammeter in parallel? The answer to this question is that it has a very low impedance because it must have a very low amount of voltage drop across it and must be connected in series connection because current is same in the series circuit. An ammeter is a measuring instrument used to measure the current in the circuit. Electric currents are measured in amperes, capital letter A, hence the name. The ammeter is usually connected in series with the circuit in which the current is to be measured. Instruments used to measure smaller currents in the milliampere or microampere range are designed as milliammeters and microammeters. Smaller scale is 0.02 ammeter. The uncertainty from reading the scale is plus minus 0.01 ammeter. The ammeter on the left has an analog scale. The reading should be 0.30